Hello, everyone. I'd like to do a quick sound check before we start. If you can hear me, please type yes in the questions tab. Perfect. I have some yeses coming through. Hello, I'd like to welcome everyone and thank you for joining us today for our virtual meetup titled The Future of AI Strategy and Innovations in Insurance. My name is Shabar Pula and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our first speaker. Michael Proksch is a Senior Director, Customer Data Scientist here at H2O.ai. And a little bit of a background on Michael. He has a PhD in economics. He was a researcher and lecturer in Australia, Singapore, and Germany. He worked his way up in the industry as a market researcher analyst in heading a data science team in a consultancy for the Fortune 100 in Europe, Asia, and the US. And I know he has many interesting stories to tell, but like coming to the US and being a principal data scientist for Aetna, and which is one of the leading health insurance providers here in the US, and now heading the insurance AI strategy and implementations of AI projects for our insurance customers globally. Before I hand it over to all the speakers, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them during the Q&A portion of the meetup. This meetup is being recorded. A copy of this meetup recording will be available after the presentation is over. So without further ado, I'd like to hand it over to Michael.
Yeah, hi, thank you, Shabar. And that sounds so great when you introduce me. And I have two more guests I would like to introduce for that meetup. And this is, can you go on the next slide, Shabar? Just to give you an overview who is talking to me. The first one is Kadir Halek. Kadir, can you join me? He is actually, he has his background in engineering. He did his PhD at Cambridge, was professor in England, and then he came to the US, worked on large-scale machine learning implementations and stochastic processes on all different kinds of industries, and now he's senior director at CVS Aetna. And supporting finance and risk management, underwriting, all different kinds of areas in that field, and it's leading a team there. Great to have you on the call, Kadir. And then, oh, you're still muted. You need to unmute. And then I have as well Olaf. Olaf is senior data scientist in decision analytics at Pacific Life in California, and he's actually designing data-driven approaches to improve decision-making in all different kinds of ways, customer experience, and works in time series, machine learning. He has his master's actually in bioinformatics and a PhD in geographic information science. And yeah, it's great to have you aboard and talk about insurance. Olaf.
Thank you, Mike.
Yeah, cool. So great, yeah. So everybody is welcome to ask questions. We will try to answer them when we get there. Do you want to add something to your how I introduced you? You're welcome to.
Well, good afternoon. My name is Kadir, and I will say good morning East Coast and good afternoon West Coast. And I'm looking forward to talking to you. Thanks.
Cool. Okay, perfect. So. What we want to discuss today is a little bit the future of AI and insurance. And let us start with, can you go one slide further, Shabar? Thank you. Why insurance is actually made, or what makes insurance unique in that space, right? So I think that, and it's my personal opinion, I think insurance is made for AI. It has its challenges and its its unique characteristics as an industry that are actually really can be supported with AI solutions, automation, and smart analytics. But there's definitely some complications in that. That's currently where I see is regulations, one big area, and I guess we're gonna talk about this today. It's legacies, where it's coming from, and then really unique domain specifics. And for example, when we talk about I worked at Aetna, healthcare, and healthcare is definitely different than other insurance areas, and I guess that's something we can also talk about. Is there anything for you, Kadir and Olaf, where you see that insurance is unique in its ways, or where it's really made for AI? Getting your opinion a little bit on that field.
I certainly agree with you, Michael. I believe insurance is very unique compared with other domains. The number one uniqueness is coming from insurance's highly regulated environment, and they have much adequate data to be able to move into artificial intelligence. Data, as you know, that's the main source. I believe insurance companies have a very decent data sets, and that would be my answer. I agree with you. I think it's the best space and best domain to be implemented first.
I would agree. Maybe one thing to add is around structured data, where it's really, I think, in insurance, as Kadir alluded to, you can go a pretty long way with a structured data set in terms of making meaningful predictions and building models without having to tap too much into the unstructured world, even though there are now use cases, of course, that we might cover later. Also, we might touch on later that talk about, okay, what can you do with the image recognition or NLP on unstructured data as well?
Okay, I think that the data space is pretty unique. You're right. So if I compare, and I love that, Kadir, because I actually haven't really thought of that on that slide. It has a highly structured data space, which we tap into compared to other industries, right? So it's actually more difficult to. Usually, it's if you ask me, in other industries, it's hard to get on data, like getting data, right? And in this case, in insurance, it's hard to find the data you really need, because there's so much data out there, right? And then I guess we're gonna talk about data as well, because I think that's also a topic for the future of insurance, right? And I actually put together, Shabar, if you could go one more slide further, I actually put together 4 topics, I think, that came up in discussions with the insurance space over the last months, when I was talking to our customers. And I'm really lucky to be in that space at H2O. And this is because we're kind of like a centralized hub, and customers really see us as, on one side, as an expert in data science, which is nice, but also like as an area where you come together, right? Our background in open source and as a visionary in the field of Automl, that is definitely helping us to spark those conversations. And I'm really happy to have you both on board to talk to me about that, and all the other customers that I have been the honor talking to about all those areas, right? And I tried to summarize it a little bit. And I think there's 4 different fields, and I know you both are experts in first of all of them, but you have specialized in 1 or 2 of them especially, and I would be happy to talk to you about that. So the first one, I think that's a great movement we see over the last 2-3 years, and it's actually pretty recent, because when I was really data scientist and I started in data science, there was nothing like that. We built that. We tried to build that ourselves, right? And I know a lot of customers doing that. So they built their own AutoML platforms where they do testing, where they will run feature engineering and all that. But at the end, it's like doing it for one team or one company. It's really hard to keep that running, right? Because it takes a lot of maintenance. And it takes a lot of, like, the algorithms come out, and there's so many new things that come out every month. Actually, it's not even year, it's every month, to keep up with it, right? So that's why I think that's a great topic we can talk about. Then the second one is definitely we have more and more capabilities now, right? When we talk about 10 years ago, we started putting credit scores in risk models in insurance, right? And that was new back in the days, right? And now we see movement in so many areas, right? It's broadening, right? We can see from a really narrow field, we see so many business cases and so many things coming up and supported by analytics, right? And some of them are, for example, image and NLP, right? And we don't even have a full idea where we can use that yet, right? Because it moves so fast, right? And then the third one, I guess we want to talk about is, and I get that more and more, that like we see that this data science is moving faster and faster, which I think is great, and I love it, because we get so much more insights than we had 5 or 10 years ago. We move so fast in that field, but then we also get to the point that it becomes really complex, right? And I think and that's what we do right now at H2O as well. We build products for example, centralization of model operations, right? And the last one, I think that's something that we usually don't really talk about, because we always talk about great models and new algorithms, right? But at the end, you know better than me, that this space is highly regulated, right? And in a lot of cases, we're bound to linear models, right? And need to provide to regulators insights, which not always possible to get with other models. So, the movement there is really slow. But what I saw, and I guess I know you, Kadir, can definitely talk about that, is the whole field of data augmentation, right? Even with linear models or yeah, in a linear space, you can do so much more if you have the right data, right? And I know, Olaf, you can talk about that as well. That this becomes more and more important in the future. I mean, this also comes with a lot of responsibility, right? Privacy and regulations, compliance, all that stuff that comes with it. But it definitely gives us a huge opportunity. So yeah, so I know I talked enough. Olaf, I know you saw H2O as well in that journey of Automl, right? And followed that whole journey. So what do you think about and where do you see that Automl solutions are quite useful and how do you use that at Pacific Life?
Yeah. Well, thank you, Michael. I think that with AutoML, where I currently see it is that we've kind of waited for it for a long time, and you've definitely said that right. Where it's something that is useful, that can help teams to have time savings and to do rapid prototyping, do some fact finding. I think that especially for smaller teams, it can be useful. That's something that has helped us quite a bit, where we're in a large enterprise setting, but we're still sometimes in startup mode, so to say, in terms of we only had a few, 3-4 data scientists to start with. And especially if we have clients or we work with teams from throughout the entire enterprise, then it's good for us to have this tool that helps you to do, especially like we said, on structured data, which is predominant in the insurance space. Especially on that data, it helps us to find facts faster and to automate some of those pieces that can be automated, including, you said it right, feature engineering, model training, some model interpretability. So those things go a long way. However, it's always good to remember also that it's not fully end-to-end. It's not fully plug and play yet, right? There's still your due diligence you have to do as a data scientist or as a data science team together with the data engineers in making sure, is this the right facts we're looking at? Is this the right data we're pulling? Are we shaping the data in the right way and then putting that right design matrix or input file into driverless AI or into our AutoML tool? So that's the due diligence there in terms of also then, and I think the most important thing is around formulating your problem, formulating your question. Are you asking the right question that is can be answered with that data, but also that the business or that your stakeholder is interested in? That's often, again, I think one of the key components. Oftentimes, is what is your target? Is your target how is a claim fraudulent or not, or is your target maybe a numeric variable on how much was the fraud amount, right? or is your target variable something like how many fraudulent claims did you have in a certain month? And are you trying to predict you have a positive trend over time? So that always needs to be tailored to the question, and that's where the data science team or any data science team really that uses AutoML still needs to bring in their own IP and their own experience and their own problem-solving skills and what not to try and what's the right way to try. So again, I think AutoML has a lot of great benefits. And for us, again, as a team, I think one thing maybe I didn't mention is around the model interpretability. I think that's in a regulated space like insurance. That also is very useful, where you can look at the partial dependence plots or Shapley values, and you get your graphs and images that you can discuss.
Yeah, I mean, you mentioned so many topics, and I don't even know where to start asking about it. I definitely love the piece that you ended up with Shapley values, right? And and I'm highly interested in that MLI space in general. But I guess one important thing is, I guess, like people ask me, okay, what do I use AutoML for, right? What is the where do I get the biggest improvement, right? Through AutoML. What do you think? Where do you think you get the biggest benefit? Like what type of projects?
I think from the time saving standpoint, really, for us it comes from a pivoting standpoint of, hey, we're 4 data scientists, but say we work on 10 to 20 projects right now. Maybe for 3 to 5 of them, you have a data set that you really have not looked at before. So again, I might have to do a little bit of pre-processing in Python or in R to maybe join 2 tables, or in SQL even, join the tables and then load them into driverless or load them into an AutoML tool. But once in the AutoML tool, I can actually start with some exploration. I can do auto visualization. I can pick my target value, set a few different parameters, and then actually explore the model training on the fly, and I can see, hey, which variables kind of emerge as a driver potentially, or as being correlated with my target variable, right? And then how does that shape my AUC curve or my my scatter plot, performance scatter plot, right? And then after that, go to the MLI and then take it with a grain of salt. I mean, that's an iterative process. That's where you're in the lab, heads down, and you're trying a few different configurations that have worked before in terms of your hyperparameters, and you go back and forth. And you can't go too deep in it, but normally that would have required me to write quite a bit of code and deal with quite some of the intricacies of the data set. And I have found a tool like driverless pretty robust to just take off some of that work off my plate, where I can just really, again, after the initial pre-processing, drop off my data in there and then play with these different model configurations, hyperparameters, and MLI things, and then think about, okay, also get an initial guess on is my performance in an area where I can accept it, depending on the problem, of course, right? There's no one such number that will say, oh, now performance is good enough, even though people would like to think that sometimes, oh, now we have AUC of 0.82, we're done. It's not, it depends, right? You can analyze more. And I really like the hovering features too. You kind of hover over, not only do you see your AUC, because one, as we know, in many classification problems, one score alone is not good enough to get an answer on your performance. So really what helps is I see the entire confusion matrix as I kind of pinpoint along my AUC curve, ROC curve. And I get a lot of other added value. I can do auto-generated reports after the fact, but so it's this initial exploration phase when I just received a data set, especially a data set that I'm not fully expert on yet for the initial exploration. That's one big thing. The other thing is, even for data sets that you have worked with for a while, and you've done your own training, maybe you've run your own models or you've built your own legacy models, so the team has built their own legacy model, you can actually use driverless for benchmarking, or just trying to get some last boost out of it, where you dial up all your hyperparameters to a pretty high number, and you try to say, all right, how much better can we do? How crazy can we go with the feature engineering? Maybe there's a new data set that you always wanted to add, but in your legacy environment, it kind of blew it out of proportion there, or it increased the runtime too much. Now you have your driverless instance or your AutoML instance, and you can add that flavor, and maybe your feature input space goes up from previously 150 variables to now 300 variables, and the Automl tool will try to look at all the different connections of them or different combinations to create new features. So that's really where you can win, and it saves you writing some code.
Michael, I think I'm going to spin this conversation in a little bit different direction.
Just one point, because Olaf, and I want to hear yours. Don't forget what you want to say. Olaf, you mentioned driverless a couple times, and you are a long H2O customer. Not everybody knows what driverless is, right? Do you want to just use one word with
driverless? That's a good point. I leave that to you, Doc.
Okay, cool. Driverless AI is H2O's Automl tool, and Olaf is using it for a while now, and he's a fan, which is great. Thank you so much. And he really helps us in improving product and performance and giving feedback from industry. And it's a great tool. We get a lot of feedback from our customers. So that's what it's called, driverless AI. And we're gonna have a great offer at the end for you guys if you want to try it out. But just to give you an insight on what that is, in case we use the word driverless AI more than once, so just that you're aware of it. So sorry, Kadir. Please go ahead.
No, you did good. My point is I want to spin this question a little bit different direction. At the beginning, I was very critical of Automl myself. I thought data scientists should be always be enough to go into the deep down algorithm. And I find that out actually it increases team's performance. That was a surprising fact I realized. I mean, using Automl actually increases efficiency completely was my earlier prejudice. I think Automl is a fantastic tool in a data scientist's hand because it does expand their vision and learning pretty fast, my opinion. At the beginning, when I realized that, for example, like Olaf said, that it gives you at least an alternative truth about your project. That's a very valuable thing. It's going to increase your efficiency. My opinion has changed quite drastically, Michael, I shall admit. And,
cool.
And the second part is the business side, right? Because we have lots of pressure from more leaders that produce more, have some financial benefit. I think Automl is increasing that efficiency quite, in my opinion.
Yeah, and I love that, especially that you say that, because Kadir is really a hardcore data scientist. He knows about every algorithm. He developed algorithms for many years as professor and then later in industry. And if you say that, that's a great thing for me, because this is definitely...
Yeah, it's like an industrial revolution, right? Industrial revolution did not make everybody unemployed, actually created more jobs. Naturally, increasing efficiency make you do more work. That is the mindset that I gained towards the end. For example, as Olaf said, that he's looking at the simple model accuracies, and he sees himself that his model is better or worse, and that's a great comparison. Sometimes you may not find an alternative or a team to discuss the details. So I think there's also amazing fact. But if you want to get a couple of more stuff in, if we have time, I believe at the end, like every other team, that we also pass through the adulthood right now. So we play with a lot of data, we're trying to find the value. As Olaf said, that as soon as your feature sets are matured, I think Automl can be more effective. Do you agree with me, Olaf? So because now it will be more investigative phase than actually solving a problem. As soon as a model factory produce models, and the domain expert can look at the efficiency and measure it. Yes, Olaf, please. Yeah.
No, definitely, yeah. I'd agree that it can be useful, but I think it's maybe also important to acknowledge that once you add so many more features, I mean, your possible feature space also kind of blows up, and it's actually more challenging for AutoML to still do well, to find really good solutions in that space, where in terms of right off the bat. So that's really where it requires a little bit of iteration, hyperparameters, those things, and just knowing the tool really well to really boost your performance. Let's say you're in a Kaggle, you want to use it for a Kaggle competition, which I've tried a couple of times. So then you really actually need to steer it a little bit more, and you almost need to create some features manually to kind of steer it in this direction where there's a lot of opportunity.
I believe it will mature to that direction, though, Olaf. Right now, it's when everything is sort of static, right? What is artificial intelligence that make his own decision?
That's right.
That's the final frontier, I expect.
Yeah, it's literally like having another lab mate with you that steers his own experiments or has his own experiments running, and then uses those benchmarks. It gives you some information back. Yeah, so I would say it's really the benchmarking, but also potential model improvements, and then the ability to take on more work in parallel.
I couldn't agree more.
Two big factors.
And I think in that space, it also redefines the role of a data scientist a little bit different. Because before, like, I mean, I spent a lot of times parameter tuning and transforming variables and looking at how to get the better model for a specific problem. And this kind of gets taken over through Automl, right? And even like if when you think about driverless AI, you can put in your own recipes, and you can definitely feed in all your knowledge in a way. It really it changes my position a little bit to a way more, like, I can get way more done, right? And I really, at first I was afraid of it, but now I really like it, right? It really changes because now I spend more time on implementing results and then getting business value out of it, right? Than before, when I spent a half a year in getting the project done, right? Now it shifts a little bit, right? Before it was 80-20, I would say. Now it's not 20-80, but it's definitely shifting towards more the implementation and how to build value, right, out of what you produce, right? And I like that you said that you concentrate more on the business piece, right? And I think that's what I see at a lot of our customers, that they can do that now, right? It frees the time to do that. Cool. Thank you so much. That's just one topic, right? And then I know, and this is a pretty new topic actually, and we all know that through buzzwords, whatever, but it hasn't really reached the insurances industry because there was no real solutions for it in the past. And I would say over the last couple of years, it really developed, and that was something like image and really, let's say, NLP technologies that are really more reliable and are more precise. So I would love to have your opinion. Where are examples, or, like, I know we're at the beginning in those areas, and I just pointed to the first two, which is image and NLP, and that's what we're working on at H2O as well. We work on a lot of others, but those are some of the primary ones. So where do you see new technologies like that popping up and helping us in an analytical space in the insurance industry? Olaf, what do you think?
You're going 2 in a row, Michael. All right. Yeah, so we're talking about NLP and image recognition. I think there's a lot of emerging use cases that I'm sure some folks in the audience have already seen. Looking at specifically fraudulent claims, trying to evaluate fraudulent claims based on looking at the documentation that was provided, so document scanning, but also maybe phone calls or emails that went with it. Looking at photographs that can estimate the value or the damage that was done on a car or some kind of property. Another one I've seen recently is around crop fields, where they look at damage on crop fields, and they essentially make that based on imagery that was taken before or after aerial imagery or satellite imagery that was taken on those crop fields before the damage incident and after. So there's a lot of emerging use cases, also in the health space, where you can now look at mammographies or skin melanoma with image recognition and detect cancer based on that, or detecting skin melanoma. So I think that there's really a lot of value there, and some of the work that was previously done manual can be performed by machines in the future. So there's a lot of emerging use cases there. For us, and I'm sure Kadir has a few points to add to that as well from his own perspective, but for us, I think that NLP has also been a tool that's coming up in solving use cases that are a little bit more, that are not so industry specific. For example, like working with call center data, or document scanning old old hard copy documents, millions of pages of documents, and extracting information from that, OCR applications. So which have, and those solutions have maybe matured a little bit more than the insurance specific ones. So I think that's also where it's interesting for us. So we're essentially building our toolkit right now and building out some of those NLP and image processing or image recognition algorithms, building our toolkit on some of the more universal applications maybe that have already been matured a little bit more. And then the insurance space, once it's ready, as we know, it moves a little slower. It needs to jump the regulating hurdles, and a lot of the data is not readily accessible, even though there's a potential. So once those use cases have matured a little bit more, we can go to the insurance-specific use cases. And I think that especially with bringing in health data where it's possible in the insurance space, maybe even bringing in device or sensor-based data in the future to bring in some of these data to make better decisions on claims, for example, it will be very useful.
Yeah, I think that one thing. Yeah, Kadir, sorry.
No, sorry. This is a very exciting topic, actually. Image processing is very well advanced already, because past applications. And anybody want to know how AI going in NLP is just say, Alexa, what does the weather look like outside, right? So Alexa was just a voice before. Now Alexa has a camera on it. And yesterday news, it was on it was on CNN, and a doctor was watching television, seeing another person has a throat cancer, but just watching him. I think Olaf is right. The future is there. We actually maybe automatically every image can recognize your issues. I think incredible features there, but as you said earlier, ethical restrictions on images are heavier than other domains. But certainly NLP, I think, is really progressing fast, my opinion. I think the proof is in Alexa today. If you ask me questions, what data scientists need to know about Alexa, I think we should have another webinar, Michael.
Yes, we can do that. And I'd love to discuss details of image processing and NLP. But yeah. I really like that you said something, and that's it is readily available, and we have that for many years, like in a way that this technology is not new, but it's definitely more available now. Let's say that, right? So there's new ways of really processing it, and I think that makes it also so, like, it is at the stage where we need to think more broadly. And I love that you came up with Alexa, right? Mm-hmm. So how can we leverage it, right? How can we leverage those new technologies, right, Olaf?
Well, you're gonna have a war with AWS.
Yeah. So yeah, I think I'd really agree with Kadir. Alexa, there's a living proof, right? There's a living proof right there on voice systems. Alexa is a great example. There's a living proof on image recognition works, right? It's driverless cars, for example. A driverless car can recognize with very high accuracy what is any object on the road and make decisions based on that. That's a big achievement. Now, how did driverless cars, for example, get there? There's a lot that went into it, right? So there we have a hardware component, all the sensors, all the cameras, LiDAR sensors, all the great things. We have a software component that we talked about a little bit already. So we have the software that can learn, but really what's at the core of it is also a huge data set of millions of images and millions of annotated or tagged images that have been made available, I think, by Google for driverless cars for the most part. And maybe in Alexa's example, even though I'm not quite as familiar with that, probably with a lot of tagged or reinforced conversations with customers, right? So we've built this very mature data set that now the technology can get smarter on. Now, where are we with that in insurance? I'm not so sure. So we also need those to make the next leap. We will also need to have very large evolving data sets. I think, Kadir, you work at Cerner, so you probably know pretty well on health record data in the health space. I've seen a little bit of that. I think in the health space it's growing, the health insurance space. In the claims space, and maybe other parts of insurance that are not so much related to health, I don't know how far it is along.
Well, my wife, her appointment is organized by Alexa. Her medical appointment, her insurance appointment. And the things that amazes me about the human adaptation. actually, we do adopt the machines more than machine adopt to us. That was my finding. Anyway, Michael, let's not to make this philosophical discussion.
No,
I can say a lot about this.
I love that, and I would love to take another webinar on that topic. But I mean, there's 2 more topics, and I'm happy to come back to it because I think the other 2 are like the second one is we're really at the beginning, because now everything is available and we need to start thinking about data as well, right? Because usually when you talk to data scientists, and that's the experience I have, not everyone, but a lot of them, when you say, okay, what can we do? And then you get the answer, I don't have the data for it, or I don't have data, or that's the data I have, right? But at the end, data is available everywhere, right? Data is there, and if you don't have it, you can collect it, right? So that's why I think we just need to start thinking, what can we do with the technologies we have, right? And then we come up with the next step, right? But if we think about like smart, as you said, Alexa or wearables, right? Smartwatches, stuff like that, that gives us so many opportunities, right? Even if you think about the smartwatch from Apple that measures your temperature and pulse and whatever it does, it's just thinking about where can we take that, right? Where can we take that in the insurance space? And I know we work on with telematic data and stuff like that, and there's definitely movements in that field slowly, because of all the data restrictions you said, Kadir. It's not easy, not currently not centralized too, right? But we're getting there, right?
Is your point trying to move the discussion into a data, Michael, here?
Yeah. So okay, good. So this is the last topic, and let's jump there before we go to the.
Okay, let's follow your order. I love your order here. Centralized of AI model operations, I believe, right? Was the next one.
Okay, cool. Yeah. So and I think it's also something in a world of more and more complexity, right? And we have more and more data scientists, we have more and more models, and we have and the deployment process is actually pretty long, right? If you think about it, it's not just the data scientist that's involved here, right? It's a lot of things that are involved in this bigger picture, right? So when we talk about centralized model operations, right? And I know, Kadir, you're thinking about this a lot because you're heavily involved in deploying models and getting models in production. Your team is doing that. So what do you think are the biggest advantages of such a centralized tool or like platform, let's say that, for model operations?
Yeah, well, this question for me, Olaf. I'm going to do the talking now. So
Good.
I think at the end, we work for a company. Our purpose is bring revenue, right? It's all about resource management. It's all about the revenues. So every job I have done in the past, it was interesting. I can tell some of my stories. When I moved to Cerner, the first thing I told my team, deploying a model. We didn't have a model, actually. I just create a simple linear regression model that predicts people's age. I said, I want this to be deployed on the infrastructure. And I repeat the same thing actually in my current job too. So the team has to understand to see the end before actually start. That's my approach. Why I ask my team to deploy a model first without not having a model? Because that is the most challenging part. Lots of people doesn't know it. Actually, it is the most challenging part. This data pipeline process is very complicated, especially in a Hadoop environment, right? We have multiple data sources. You have a real-time data. Combining all this is complicated. If you have a centralized model deployment environment, it can cut your costs radically, actually. Because imagine that we have 10 models, on average, your engineering team spend 10 days for just deploying one model. You make 100 models. If you have 1,000 models, are you going to hire another 100 data scientists? No, of course, right? So that's what it has to be automated. That is the end. My opinion, this is the most important part for the corporates. We have to manage how to deploy. This is a classic history of any technology. Imagine that virtual machines in Linux, right, in bare metal. So we come up with the Dockers and containerizations. We automate every process. I think this is another important topic that can save money and speed up the AI applications. Please ask me a question because my mind is scattered right now. So
no, I couldn't agree more. So Olaf, do you want to say, because that's so, we can talk about this for another hour, right? Because this is such a central topic, and I know that because we started developing a solution for that at HO, because we saw this as a bigger problem for our customers, but like how is that at Pacific Life, Olaf? What do you think about AI and model operations?
I think it's very important to do a good job on model operations and deployment, and be aware of things as model drift and decaying models, as we have said. For us, we use semi-automated and deployment of models, even where we use outputs and we just feed them forward into another receiving system. And then we do some of that monitoring in semi-automated way, I would say. But as Kadir said correctly, to scale, it's very important to have a fully automated way to be able to take on or deploy models, 50s of models, hundreds of models. So it's definitely the factor that will let you scale and pivot at the end. And that as those solutions mature, you can take on more models and keep them in production too, right? Because there's always this point of, okay, your model is ready, you think it has been approved and you're ready for deployment, but then, as we know, the process does not end there. We need to actually keep monitoring and make sure that the model drift or model decay does not happen and the model still stays up to date. You need to retrain, make sure it's still fulfilling assumptions along that way when new data comes in. So it's very important.
Yeah, I mean, I totally agree. And there's definitely a lot of risk around of AI that can be solved along the way as well, right? Through centralized model operations, right? I mean, that's something we usually don't talk about, right? That's risk, right? And that's risk and errors, right? Human errors, right? In the long process, right? You say we can be faster and we can be better, but on the other hand, there's a lot of inefficiencies, yes, but there's also a lot of errors if we have manual processes, right? And if we can find a standardized framework for that, we can definitely exclude a lot of errors on the way, right? That's something and we can have a totally topic, a webinar about risk in AI, right? And I would love to have that, because that's something what we can and should address, right? The model ops can do it. That's for me. That's the most important point for me, right? Where you can actually exclude human error in a way, right? So, and then there's another one, and I want to go to the last topic before and it's almost over again. So, but I want to talk about one field what we usually try to avoid, and that's data augmentation, right? We have so much data, right? But we are really, like I said, I usually get the answer, that's the data I have. And I know healthcare and insurance has a lot of data, right? There's a lot of also data that's around, like scanned documents and a lot of other stuff. We have claims, we have data about whatever, and there's a high privacy piece to it. But I like the idea, because I know you've been doing that in that, Kadir, the space of data augmentation, because especially in the highly regulated space, right? If you cannot really change the model you're using, because you already have a linear model and your regulator wants to see a linear model, right? You cannot really change a lot of like, you cannot really improve it by adding way more interactions or making it more complex, because it's regulated. The regulator wants to see it, right? So and yes, we can, even if we move to GBMs and newer models, neural networks and whatever, we will reach a limit, because the data is not reflecting every single circumstance around a member, right? And I saw that data augmentation can boost performance so much, right? And I don't know, Kadir, do you want to say something about it? Because I know you're the expert in that field.
Yes. I believe we have 15 minutes. We should give some time to the audience, but I'm going to be a little futuristic, a couple of minutes, I believe, to excite the listeners here. Data is certainly the fuel, right? We all agree on that. And you will be surprised these days, there's lots of hedge fund actually treating data as an asset, like a future trading, right? You're going to buy gold and oil or maybe cotton. So they're treating data right now like an asset. And I guarantee you that for more than 100 data startups, they're seeing data as an asset. Isn't that amazing? So this means that it's very, very important. Your second question is, how do we use that? It's very well regulated, which I agree with the regulators. Certainly, I think HIPAA is necessary. Privacy rules are necessary. I think we should be very careful. Especially at Aetna, we are incredibly careful because we respect privacy. That's our number one point I need to make here. Your data is safe in our hand, and we do respect privacy. I think with a proper ethical behavior, data can be shared effectively. So we do use actually third-party data assets, but of course very carefully. So I believe there will be a short words than I can just told you. Please, a small question if you have any specifics, you can answer.
You know, I mean, I don't want to go in details because I know it's an asset, and I know that companies treat that on a really confidential basis, which is great. And I think we should do that because there are so many regulations and privacy and stuff related to that. I just want to ask you in general, how much did you see, like, how big was the improvement by using wisely using external data? And I don't want from you a number. It's just like just an estimation of yeah, it was a lot, or we could see it in some cases, or we see it big.
Yeah, it's a relevant question, right? If you do not have person's data, you need to have that data. So from 100% to, I will say, a lower level. Depends on your requirements, right? If you want to do a marketing outreach, maybe it's not very effective. But if you're looking at people's health, you need the person's data. It could change from 100% to 1%. Depends on the application, Michael. So, oh, yes. Of course, there's always a missing data, right? So we do implement machine learning techniques to fill the data as much as we can, but the real data is irreplaceable.
Yeah.
Does this answer your question?
Yeah, no, I agree. Yeah, it's hard to ask because it's really domain specific. So I can definitely say in my experience that if you know which data is important, you can boost the results a lot, right? And that's something I wanted to go to. That's where I guess that's a big field in the future to really see that more as an asset, right? To see that how can we use data, and then a good GLM and well calibrated can be as good as a GBM if you have the right data, right? Olaf, what do you want to say?
I think I agree with you. I do not discriminate machine learning algorithms, which I love them all.
I would agree. I would agree on that.
If GLM will work, let's do it. Who cares?
Not going to take any sides. Yeah.
My company, shall we use logistic regression or deep neural networks? And I have to stay between. I love both of you. So
that's true. Yeah, but I definitely saw that GLMs can be really accurate if they're well calibrated and you have good data, right? And then but I totally agree. There are pitfalls. Let's say that. Olaf, you're holding back. I can see that.
I know, that's fine. I think Kadir said a few great things that I think apply for Aetna, but I can also reiterate for Pacific Life, especially. I think we have a lot of regulation we talk about, but also specifically when it comes to machine learning and putting machine learning algorithms into practice. There's a lot of emerging guidelines on ethics that are coming up. So a big one is privacy that Kadir mentioned correctly, but we also have the fairness, talking about bias a lot, and things about transparency and accountability in these spaces. And I think as we grow as analytics practitioners or as an analytics and data organization, this is something we also take very serious, and that especially whenever you add a new layer of data and you connect another dot, is something that you always have to ask that question and work closely with people in that space that can answer these questions. And now as more guidelines get put into place, I think that will be a requirement for machine learning applications to evolve and to say, okay, we can really add another data point. Maybe we have to aggregate to another level to respect those privacy issues and to do the right thing. But the boosting can really happen with the data augmentation. For me, a mantra we had, or I've seen throughout my career, is that better data usually beats better models. Now, AutoML is a little bit on the other end of that spectrum. Now, I would agree then, okay, we can always find a better model if we have sufficient data. So you can turn that statement a few ways. But so the data augmentation, I think, has huge potential benefits, but if it's done the right way, and if you respect those emerging guidelines, and as it is a new field, or machine learning applications are a fairly new field, it turns out some of those guidelines are, I think, still being written and still being agreed on. So it'll be a little bit of a latency there.
Yeah. No, I couldn't agree more, right? But I know we have to wrap up a little bit. Shabar, I know we have questions, and I see them coming. Shabar, do you want to take over and go that way? Oh, yeah. Before we end here, I talked about driverless AI, right? And I want to give you the chance to really try it out, right? To really go, you got to get a 21-day free trial from me today. If you go on that link, you get a chance to really try out Automl, for example, and you have the other stuff, some of the other stuff included there as well. You have image recognition in there, you have NLP stuff in there. If you can try that out, and I would be happy to have your feedback, right? When we go now over questions, and if we missed a question, right, please don't hesitate to send us an email, right? Send me an email, michael.proksch@ho.ai. Right, and I'm happy to follow up and then have a conversation if we miss the opportunity here, right? Okay, sorry, Shabar, you're welcome to take over.
Thanks, and thank you guys for a great presentation. We have several questions in the questions tab. I'll start off with, an attendee said, I have been working on a similar problem. Since OCR isn't perfect, how does one go about choosing the right one for them?
Okay, anyone? So who wants to start? The image experts, Kadir?
OCR naturally, yeah, when I was at Cerner, OCR was a big thing, still a big thing. I really do not know what type of algorithm he's after, but certainly please email me. I can walk through his algorithms and help him right now. It's such a wide topic, and I believe a couple of highly specialized algorithms. Michael, do you have H2O as OCR algorithms in your tool sets? I'm not aware. So
we do have some OCR stuff, yes, which is not open source available, yes, but we do that, and we do that for some customers where we build OCR technology. You can also use driverless AI for image recognition, but again, this is not, it's not like we're having an out of the box solution for that.
Yeah, it depends on, of course, application, right? If they're scanning, what type of documentations is automated, what type of noisy environment they're appropriate, I can help. Olaf, I believe, take the microphone from me here. I don't want to go deep down the algorithm today, so.
Great, thank you guys. The next question is, healthcare is full of dark data, whether it's scanned documents, PDF, photo frames, etc. How hard is it to develop AI solutions built around automatic analysis of those?
Oh, I would say that depends. And I don't like that phrase, but it really depends. It depends on what you want to do with it, right? There's definitely a lot of opportunities on that one, but and I saw quite a bit because I've worked on stuff like that, not necessarily in healthcare, but it can really help to, and that's a lot of information, as you said, to really go through information and see what's available.
I can actually ask, this is a good question, by the way. There's so many data sources, and as a data scientist, we always have to think about an entropy. Which one carries the most information? What I need to do? That would be the first question. The second one is the hard work. Measure my information, how big it is. Yeah. If it's a text data, and what is the business domain I'm after, what am I doing? And the secondly, is about how can I absorb this data, what type of tool I'm going to use. I believe it shouldn't be that difficult. Lots of tools there can help. And I will go one at a time, not combining these three complicated data sources, mixing image, mixing text data. another data science challenge, in my opinion. I will be very careful on that because naturally, yes, deep learning algorithm can handle that, but it'll make things make life very, very difficult. Yeah. Do you agree with me, Olaf, in this case?
Yes, I would agree. First of all, maybe I'd take a step back here and ask, okay, what do we mean by dark data? Maybe not everyone in the audience is aware. So actually, in a large enterprise setting, I think there's dark data in terms of things that haven't been analyzed, or data sources that are not things that aren't being captured at the moment, but also maybe just data sources that are in analog form somewhere on printed documents or tapes, right? And it might have to digitize first. So dark data goes a long way, and that are therefore hard to analyze. And now, from my understanding, dark data actually extends even further into the web or cloud or whatever you want to call it space. Whereas what other information exists that you could potentially leverage that pertains to your own entity as an enterprise, but also maybe has useful information that you're not leveraging, right? So it's really actually endless at some point, the dark data space. So I'd agree with you, Kadir, to say it should always be problem-driven or solution-driven. What would you like to do? And then think of dark data more. Dark data is normal. It's kind of a negative term in a way, and it's an overwhelming term too. It's like, wow, there's all this dark data. What are we going to do about it? How do we shine the light on it? It's hard. So, but maybe a data augmentation we've discussed about it is a good answer. Maybe think about it more. What data? What information are we missing right now? What is information? Let's say we have a model that's maybe 70-80% of the way there. What is that remaining 20% that we can't answer today? And how much do we think of that 20% can be answered with some additional information? What do we think is actually the remaining part that will be very, very hard to answer? We should probably call it quits and move on to another problem. So that's where the dark data comes in. Now, obviously, if you have an enterprise that has been around for a long time, it is true that there is a large amount of in-house dark data, I would say, or maybe in a positive phrase way, of potential data sources that can be added. So it's definitely something to be aware of. We think of it also in data silos sometimes, or in just potential additional dimensions that you can triangulate. So I think it's important, but maybe we'll rephrase it and determine something more positive.
Yeah, I think I can answer this question a little bit different spin. If he is really curious about more R&D style approaches, there's lots of the binary data level algorithms is coming really, really fast, especially factorization methods of purely working digital, basically byte order. So he can just play with them if data is such a nasty. So that will be a fun things to do, I assume. Yeah, I will stop here.
I like what you said, Kadir, about the looking at the business value, right? It is an asset, right? And sometimes we forget about it, right? And then I had discussions when people came to me and said, okay, that's all the data we have. So what can we do with it? And I really like that way of looking at it, because then you don't forget that you have a lot of data. You just don't put a value or you don't consider it as an asset, right? And breaking down silos, I guess that's something. I mean, everybody's talking about it for many, many years, right? Especially in the digital space and so on and so on. But there's not a lot of companies that really achieved that over the last 10 years, right? We all claim doing it, but at the end, this black data is pretty big in a corporate world, right? We're moving slowly. I'd say that. Right?
Thank you, guys. Did you have something else? Okay, this question comes up quite a bit in our sessions. So will AutoML be disruptive in the future for data scientist jobs? Though we clearly know it cannot replace the data scientist, what do you feel?
Oh, that's a good question. Kadir, do you want to?
Actually, I answered when I start my conversation at the beginning. I think we shouldn't be fear on technology. Something going to happen, it will happen. We have to see, like at Star Trek, right, the frontier. That's why I'm approaching it. I believe instead of seeing as a challenge, I will challenge the application myself. Naturally, it's going to help us, but my intuitive answer to this question to data scientists is, I will say, in 5 years, data science will be heavily algorithmic oriented. Basically, your IP will be your secrecy, will be an algorithm that you develop. You can keep this as an internal IP. That will be my answer. AutoML certainly going to make lots of hard problems easier, like an ETL process going to be simplified, model deployment going to be simplified, training going to be simplified. The only things left in here is algorithmic solutions. That will be my approach. Please, Michael, I think this is a good debatable topic.
I mean, my background is also in consulting and economics, and I think the job changes. That's right, and it's inevitable. So we will move right slowly, right. You were a statistician 15 years ago, and now you're a data scientist, right? And in 5 years, what's next, right? And I think it does not have to be negative, right? It could be that we move in a way that we move closer to what we can do with it, right? And that like we can get out of this area where we spend most time on programming and calibrating, and we can spend more time on how do we want to bring value to members, right? Everybody out there with AI, right?
I think it's a sin that we have to pay the price. We call ourselves as an artificial intelligence expert. Here you are, guys. There's artificial intelligence, the challenge, you could do it. You know, I never called myself AI expert before. These days, everybody call themselves. If you calling yourself an AI, there's a challenge, so we have to fight for it.
Okay, great. Thank you, guys. And one question, if you guys can each answer this in about 10 seconds each, that would be great. Where do you see AI in 5 years? Olaf, what do you think?
I think that AI has to get more connected still in itself. If you talk about insurance space, a little bit more with the regulation and ethical guidelines we have set, but in the future, I also see it more connected with devices, sensors, talk about IoT, smart contracts, maybe blockchain. So I think there's a lot of value if we connect the dots some more.
Perfect. Kadir?
Another beautiful question. 5 years is a very short time, but I think in 5 years, I have to answer because most of the audiences are data scientists, and how much money I'm going to make next 5th year, right? So that will be the question is, you know, how safe my job is. I believe start working mathematics and algorithms, that will be a way of escaping it. That will be my approach. And so in terms of futuristic technology, self-driving cars coming. I have a friend actually start a company doing a virtual rest software inside the car. Basically, they help you inside the car. So technology, we can list thousands of different applications, but in terms of our job security, I think we should focus on specific talent sets. And we should focus on a little bit more algorithmic approaches, mathematical background. That will be necessary in next 5 years. That, of course, Olaf we can list so many futuristic visions here, but at the end is what matters our life.
Yeah, I think that was a good answer from an engineer perspective, right? And I love that, but I totally agree that I think that like what is a data scientist right now, right? If you look at the job description for data scientists, it's like the golden egg, right? And you're a business consultant, you're analytical expert, you're a programmer, you're everything, right? And I think in the future it's going to be more driven, and AI is going to be way more evaluated on what can it bring, right? What's the return on investment? And the data scientists get like, it's already the case that they get measured on what do they bring to the business, right? And I think that's where AI goes in producing value, right? And then however to define value, it could be money, could be life, could be whatever it is, right? And I think that's where AI goes, if you ask me, right? As a data scientist, I think that's you need to understand the bigger picture, right? From the beginning to the end. You start, and like what you said, Kadir, starting from the end, from the value. Okay, good. That was a little bit more than 10 seconds. Thank you.
Okay. Well, thank you for that. We do have a lot more questions that we weren't able to get through, so I think we'll follow up with this as a blog and answer some of those questions that way. I want to say thank you to Michael, Olaf, and Kadir for taking the time today to do a really great presentation and talk. And I'd like to say thank you to everyone who joined us today. I will provide the recording and the slides in a follow-up email to you. So everyone, just have a great rest of the day. Thank you.
Thank you very much. I'm looking forward to having you.
Thank you, Kadir. Thank you, Olaf, and thank you.
Perfect. Thank you.
Okay, are we out?